Lesson 4, the triangle inequality. Did you know that if I just handed you 3 lengths, 3 numbers, that you can't always make a triangle out of those 3 lengths? It kind of depends on whether they're big enough or small enough, depending on how you look at it. And this is where the triangle inequality theorem comes in. Here's what I like to do. If I handed you the lengths 5 feet, 10 feet, and 12 feet, could you make a triangle out of that? Well, I already kind of made the picture. But here's the strategy. If you take that longest length and you consider that to be, let's say, the river, and we're trying to make a bridge across the river. If we used a 5-foot board on this side and a 10-foot board on this side, would they reach across the river? And the answer is yes, they would, because 5 plus 10 is more than enough to make it across a 12-foot river. So how we know that makes a triangle is because the 5 plus the 10 is bigger than the 12. It makes it all the way across, right? We're on the second example. If the lengths I gave you were 5 feet, 4 feet, and 12 feet, those can't make a triangle together. You cannot connect those 3 lengths to make a triangle. Again, our strategy is to take the longest of the 3 lengths and think, okay, could I reach across a river with a 5 and a 4 if the river were 12 feet wide? And I would say no, and therefore that doesn't connect. They can't connect to make a triangle. And why can't they? Because the 5 plus 4 was only 9, and 9 is not bigger than 12. That's actually how we're going to write it. We want to try to see those 2 smaller segments adding up to be greater than that longest segment. The triangle inequality theorem, the sum of the lengths of any 2 sides of a triangle is greater than the length of the third side. And like I said, the one you really need to check is when the third side is that longest side. Let's do a couple of examples. And when you're first starting, it doesn't hurt to draw out the river. So I've got a river here that is 12 wide. Why did I choose the 12 for the river? I could have chosen the 2 or the 11. It's because I always want to pick out the largest one to be the river. Now let's think about if I had a 2-foot board on this side and an 11-foot board on this side, would it reach across? Well, 2 plus 11 is 13. So I think that they would reach all the way across. They would just barely meet, right? But it would make a little triangle. So my answer to this one is going to be yes. But then I'm also going to have you give an explanation. And the explanation that I want to see is about those 2 shorter lengths adding together to be greater than that third side. So a complete answer will have a yes or no, and it will have an inequality. Let's do one more together. Can the lengths 11, 6, and 5 form a triangle? Which one of those am I going to make my river? Always the longest one is my river. So I've got an 11-foot river. Can I reach across an 11-foot river with a 6 and a 5? I would say I could. A 6 and a 5. But can you see that it wouldn't really make a triangular bridge? It would be just big enough to span across that 11, because 6 plus 5 is 11. So you actually wouldn't be able to make a triangle out of this one. The answer is no. And the reason is because the 6 plus 5, is it greater than 11? No, it's equal to 11. So I'm just going to put a slash in there. That's going to be your explanation, that the 6 plus 5 is not greater than 11. Every time we're checking to see if we have that AB plus BC greater than AC relationship. So every time I want to see the greater than sign, whether it is greater or whether it is not greater. Go ahead and try 1, 2, 3, and 4. Make sure you give me the yes or no and the inequality to back up your answer. Number 4 has you think just a little bit harder. I think you can do it.